Hi, I want to talk about a topic we need to get covered. It's called arc length and sector area. All right, so if you remember the way we defined a radian angle, we talked about drawing any circle over at any radius and marking out an angle theta, and then there's this length along the circle called the arc length that theta determines. And so we define the angle theta as S over R. So the key thing is then we ended up seeing that 180 degrees is equal to pi radians, and so that allows us to convert between degrees and radians. So the thing is measuring radian angles is very difficult because measuring that arc length is difficult. So in the practical world, whenever we're measuring angles, we usually measure in degrees, and then we can just use this conversion to convert it to uh, radians if necessary. So, like I just said, we don't really use that definition to figure out what radians are because the arc length is hard to measure. But what we can do is, if we know that angle and we know the radius, then we can take this formula, theta equals S over R, and solve it for S. All right, and so if you think about it, you'd multiply both sides by r, and you'd get S is equal to r times theta, and that's called the arc length formula. There's one thing you got to be really careful of, though. This came from the definition of an angle in radians, and so if you're going to use this formula, that angle needs to be in radians. All right, but otherwise, it's a really straightforward, simple formula to work with. All right, and so say I wanted to find the arc length that's pictured right here. And so I have an angle of 11 pi over 6, a radius of 10, and I want that arc length. So I just use this formula right here. What's important, how do we know that angle's in radians? It's because there's no degree sign there. Okay, remember, an angle, a radian angle doesn't necessarily have to have a pi written in it. But the key thing that makes something a radian angle is that there's no degree there. There's no unit at all given. All right, and so our radius is 10. Our angle is 11 pi over 6, and that's in radians, like I said. So now you can just plug that into the formula. All right, and so S is R times theta. We get 10 times 11 pi over 16. Remember, that's 10 over 1, and we multiply fractions straight across. And so we end up with 110 over 16. We always want to reduce that. Now, you might be wondering about what the units are there. S is an arc length. It's a length, and so it has the same units as the radius. So there's your exact, there's your approximate answer. All right, so let's look at another one here. Here I'm starting with a angle of 20 degrees and a radius of 5 feet, and I want the arc length. And so here's my formula, r theta. So I just plug in 5 times 20, right? And that gives me 100. Now stop and think about this, though. I actually set you up here if you were just following along. This radius is only 5 feet, and this is a small angle. Is there any possibility that that arc length right there is 100 feet when this length right here is only 5? That doesn't make any sense. All right, and so usually you can catch that mistake. Do you see what my mistake was? Is remember, to use this formula, theta needs to be in radians. Okay, and I used a degree angle right there, so all of this work is incorrect. And again, just notice you should be able to catch that. If you forget to convert to degrees, you'll get answers that are way bigger than what you would expect. All right, so we need our angle in radians. So the first thing we need to do is convert that to radians. Remember how we convert. And so in radians, that angle is pi over 9. So now we just plug into our formula with the radian angle. We end up getting 5 pi over 9. You calculate that on your calculator, which is 1.75. And that makes a lot more sense. If this distance is 5, this is going to be smaller than 5. All right. So that's arc length. And then there's a related formula that gives the area of that pictured region. So whenever we have these kind of pictures like this, that's called a circular sector, and we're talking about how to find the area of that thing. All right, and so the way we do that is we look at the picture, and we can actually use similarity to figure out what that is. And the key thing is we have this angle theta right here, and we know its radius. All right, so the area of the sector that we're interested in divided by its angle theta will be equal to the ratio of the area of the whole circle to its angle. By the way, this is a derivation. We're going to get to a formula. If this ends up confusing you, don't worry too much about it. All right. So the area that we're looking for over its angle theta, this is the area of the whole circle, and this is the angle for the whole circle. All right, and so notice that the pi's divide out right here. Now all I have to do is isolate A. I would do that by multiplying both sides by theta. Like that. So you can see that there. We get theta by itself. So the way it comes out from the algebra is r squared theta over 2. This is kind of like the area of a triangle formula, or you can think about it as being 1/2 r squared theta. All right. Again, important, this formula comes from theta being in radians, and so to use this formula you need theta in radians. But otherwise, it's fairly straightforward. A few things to be careful of. Only the radius is squared. The 1/2 and the theta are just their value. If you're wondering, if you folks that keep up with units, how does this give you area? We have two variables. There's an r squared. It seems like you'd pick up another unit right here, but remember radians don't really have units on them, so that is an area right there. A couple quick examples here. So if we find the area of the previous examples, we had a 10-foot radius and an angle of 11 pi over 6. That's already in radians, and so I can just use the formula straight. Just got some more complicated fractions to deal with. And so 10 squared is 100. You go through all your reduction and canceling, and you end up with an area of 275 pi over 8 square feet. All right, because it's an area. All right, and then if we come back to this example again, just to use both of these formulas, arc length or sector area, the angle needs to be in radians, so we get the angle in radians again, and then we just plug into this formula. R is 5, so remember that's the only thing you square is the radius. Like that. Go through your fraction operations, nothing reduces right there, and so you end up with 25 pi over 18. There's its approximate square feet. That's it. Two simple formulas. The main thing to look out for whenever you use them is to make sure that your angle's in radians. All right, I hope that helps.